Alright, so chapter 10 review, getting us ready for tomorrow. That's the one with the answers on it already, which you can find that on Schoology as well. So if you just kind of want to check your work and you want to see just check your answers and then maybe be able to fast forward to this video and not have to watch the whole thing, that would probably be your best bet. So let me get this guy open. Here we are. All right, so I kind of started off. The first part of the test is multiple choice, and basically it's going to be plug and chug. As long as you know the formulas, you're going to be taking the given dimensions, putting them in the calculator, finding either the surface area or the volume. So I anticipate about 70 to 75% of the points are going to come from the multiple choice. And then the tougher problems that are similar to what we did in 10.5, the word problems, those will make up the final 25% on the free response. So let's go ahead and get started. So we have this rectangular prism, this box, for surface area and volume. You're going to find that volume is much faster and easier than surface area. So this box is going to get filled up a little bit more. All right, so let's do volume first, just because it's easier. We'll knock it out. So volume for any box is just length times width times height. Or, in general, it's the base area times the height. And since this shape is a rectangular prism, the base is a 7 by 8 box. So 7 times 8 is 56 times the height, which it has a small little height of 3. And so my final answer there would be 168. And we're looking at cubic yards. And you could write it CUYD or YD3, whatever you'd like there. All right, surface area is going to be a little bit tougher, and I kind of just do it old school, and I just add up all my sides. So I'm going to view it as first I'm going to do the top and the bottom. So when I do the top and the bottom, I have 56 for the top and 56 for the bottom, 8 times 7. Then you might want to do, the front and the back. So when I focus on this front one, it's 7 by 3. And that should match up with this one back here. That's also 7 by 3. So those two are 21. And then finally, I have the sides, which you can barely see, but the sides are 3 tall, and then they are 8 long. So you have 3 by 8. So this is the right and the left, and that's a 24 and a 24. And when you gather up all that stuff, it is 202. And there's other ways to do that, for prisms and cylinders. There's also, if you would like to use, the surface area is 2 base areas, which is basically what this is. This is 2 base areas, the top and the bottom. And then you add to that the perimeter times the height. And basically, this right here takes care of the perimeter times the height. Because you're kind of getting all 4 walls at one time. So you're kind of saying, hey, this is 7, this is 8, this is 7, this is 8. So that would be 30 for the perimeter. And that whole box right there, everything, all the walls all the way around have a height of 3. So if you do, 2 base areas plus the perimeter times the walls, that will lead you to the same answer. I don't know if we need another formula to have to memorize. I just usually don't do it that way, but you totally can. That will be fine. All right, moving right along. Next problem, we have a hexagon prism. So again, it's got 2 base areas. So doing I'll stick with surface area on this one. Basically, we have 2 base areas plus all the rectangles, and we have 5 rectangles, the 5 walls, and every rectangle should match one of these. They're all the same, and every one of those dudes are 9 by 9. So the wall shouldn't be too bad. That would be 5 times 81. 5 walls, and every wall has an area right inside here of 81. 9 times 9. The 2 base areas, well, the base area for any polygon So the base area for this one is 1/2 AP, 1/2 apothem times perimeter. So we have 2 times 1/2 times the apothem, which is right there, times the perimeter, which is, basically 9 times 6, so that's 54. And then we're going to add that to the 581s, and I believe that comes out to be somewhere around 907.2 square inches. Remember, surface area is always square units, volume is always cubed. And again, you could have used, if you prefer the formula, you could have used 2 base areas plus perimeter times height. That totally would have been acceptable. That would have worked. All right, volume. Volume again is just base area times height. So we've already got the base area right here. That's already worked out for us. So the base area is 1/2 AP. And then we're going to multiply that by the height of the prism, and I ended up with 1895.4 cubic inches. So there's my volume, and this formula right here represents the base area for hexagon. All right, number 3, moving on down, I have a cylinder. Which cylinder, you're probably going to want to peek at your formula sheet. I mean, we can derive both of these. And this cylinder, some of you might want to redraw it and kind of have it going up and down so it looks a little more normal. Has a height of 9. And then diameter really isn't as helpful as radius. So I'm going to cut that 8.5 and say that it has a radius of 4 because that's what's used in the formulas. So surface area. The formula for surface area is 2 base areas, so 2 pi r squared, because that would take care of the 2 circles. And then the lateral area is just a big rectangle that is basically circumference times height. All right, when you open up that cylinder, it kind of looks like this, where the length of the rectangle has to match the circumference of the circle for it to all fit together properly. So now I'm just going to come in and I'm going to put my numbers in. 2 pi 4 squared plus 2 pi 4 9, and that's 16 that's 32 pi's plus, looks like 72 pi's. So a grand total of 104 pi. Now that might be the answer. If the test has that as a choice, that would be the exact answer. Or we could multiply it out and we would get somewhere in the neighborhood of 326.7, and our units are meters squared. Now volume, because this still represents a prism type of thing, a prism or a cylinder, it's just you find the base area and you multiply it times the height. I mean, that's all it is. It's still BA times H. Just my base area is a circle. So this one is pi 4 squared H, which that shakes out to be 144 pi, which turns into 452.4 meters cubed. All right. So there's our, there's kind of our basic ideas of cylinders and prisms. So now we're going to jump into pointed objects. So the main difference with these comes in volume. Volume of any pointed object is 1/3 of the base area times the height. So the only thing that's added is that 1/3, because you find out that if you made a funnel out of these things, and it's kind of like if you have this cone down here at the bottom, if you turn that into a cylinder and you had that cone that fit perfectly inside of there, like just perfectly inside, and you actually took that cone out and used it as a funnel and filled it up with sand or water, you would find that when you fill that thing up and try to pour it in there, you can get exactly 3 cones in a cylinder with the same radius and the same height. So that's just a property that pyramids and cones share. So that's something kind of cool that we talked about in class, and I kind of did some demonstrations of that. So let's crank these things out. So surface area, and for some kids it helps them to draw a net. You know, some kids like to open this thing up and see what it would look like if it was in 2 dimensions. It's called a net. Some kids like to do that and find it out. Other kids can just visualize it. So I'm probably not going to draw a net for everyone, but I'm kind of thinking that I have a square plus I have 4 triangles. I mean, that's basically, if I was going to build this thing out of wood, that's what I got to do. So the area of a square is just base times height, or side times side, so that'll be 16. 4 triangles, well, that's 4, and the area of a triangle is 1/2 base times height. So I got to kind of look at this triangle, and right here is the base of that triangle, and right here is the height of that triangle. Now, as far as the pyramid's concerned, this is called the slant height. All right, 8.2 is technically called the slant height of the entire pyramid. But 8.2 is also the height of that outside triangle. So I'm kind of just viewing it as a height of the outside triangle. So I have 16 for my floor. I have 4 walls that are all triangles, 1/2 base times height, actually slant height. And that shakes out, go through here, comes out to be 81.6 square yards. Now, volume is a little bit trickier. You know, volume is 1/3 base area times height. So my volume is going to be 1/3. The base area is pretty easy, 4 times 4, that's 16. Now, what's tougher on this one is I don't have the true height. You know, I have the slant height of the pyramid, but I don't have the true height. So I'm going to drop down. Let me erase this blue line so it doesn't get quite as confusing. But I'm going to drop a height right down. I'm going to drop a height straight down into the center of that square. And then I'm going to shoot over to the center here at 90 degrees. And why I'm going to do that is because it's going to allow me to use the Pythagorean theorem. So I know, since this whole side of the square is 4, that this halfway is 2. So kind of coming over here to the side, I have this triangle that I can now solve. I'm looking for the height. The bottom is 2. The slant height is 8.2. And now we can set up Pythagorean theorem. You know, I can say, hey, h squared plus 2 squared equals 8 squared. So h squared plus 4 is 64. Subtract, I get h squared equals 60. And h turns out to be the square root of 60. Now, I don't have to get a decimal right now. I can just leave that alone. And I'm just going to come right up here and I'm going to stick that h in there, square root of 60. And I'm going to crank that out, punch that all into my calculator. And I believe that I got 42.4-ish. You know, there's some rounding going on there. And if you did punch this in, I think it came out to be somewhere around 7.95. So that one involved having to do the Pythagorean theorem to crank it out. All right, so moving right along. Number 5, surface area cone. You know, you're just pretty much gonna have to have this one written down somewhere. So surface area cone is a little tough. If you draw the net of it, it's actually a circle with kind of a sector of a circle, and that would fold together to make the cone. And it's a little tricky, but you have the base area plus the walls turn out to be pi RL, pi radius slant height. So this 13 is my L. I don't have an H right now. I don't need the H for surface area. I will need it for volume, but I never need the height inside, because surface area is just referring to the outer surface. So let's crank this out. I have pi radius squared plus pi radius slant height, and slap all that crap together, you get 90 pi, and that shakes out to be 282.7 square meters. So that would be the surface area. Volume is same as what we said before. It's 1/3 and times the base area, which is a circle, times the height. So it's still 1/3 base area height. And now I'm going to need to do some Pythagorean theorem. Instead of doing all that work again, the setup would be 8 squared plus 5 squared equals 13 squared. But this is one of our triples that hopefully you can memorize. 5, 12, 13 is a triple that works. So we can speed that up a little bit and not do the Pythagorean theorem work. So 1/3 pi radius squared times our newfound height. Boom. And that looks like about 100 pi, and which shakes out to be 314.2-ish cubic meters. So there's your cone. All right, moving right down, number 6. Trying to keep this video not too long. Surface area. So I'm looking at this shape and I'm seeing, hey, I have 2 triangles plus 3 rectangles. Now they're different sizes. So my 2 triangles, when I look at this triangle, I notice that I don't have a right angle. So I see this little height drawn in right in here. This little height is 4.5. That's this red line here on the drawing. And then the base that the height meets or runs into is down here at the bottom. It's 10. Now the base is not always at the bottom. You have to look and see where the height hits it at 90. That cues you in and tells you who to use for a base, where that 90 degree is. That's where the action's happening. So I have 2 of those. So I have 2 triangles, which are 1/2 base times height. And when I do that part, that shakes out to be 45. And now for my rectangle. So there's 2 ways that you could do the rectangle separately. So if you do them separately, you have a 10 by 7 in the front. You have a 5 by 7 on the side. And then you have a 9 by 7 on the back wall. So that's the 3 walls. Those are the 3 rectangles added together. Some people prefer to use the pH formula and to do perimeter times height. You could get that as well. But either way, comes out to be 168. And so 45 plus 168 shakes out to be 213 square yards. And so sometimes it's easy to get all the walls just at one time if you'd like to. So if you kind of go that route, and some of you may decide this is what you want to do, but the perimeter is 10, whoop, get some color going here, 10, 5, and 9. So that's 24 times a height of 7, and that will also give you 168. And that's just getting all the walls in one swoop. All right, volume should be easier. Now this is not a 1/3 because this is not a pointed object. It's not a pyramid. It's not a cone. It's a prism. It's got 2 congruent parallel bases. So volume is just back to being base area times height. Well, the nice part is the base area is right here. I already have that. It's 1/2 base height. And then the height of the prism is 7. So we crank that out. And I get 157.5. And that would be yards cubed. All right, number 7. Tougher pyramid. This is the square pyramid is the easiest. Rectangular pyramid is a little bit rougher. Volume is no big deal. Let's just crank that out. That's pretty easy. Pointed object, so it's 1/3 base area times height. So we got 1/3. Base area is a rectangle, so it's just 12 times 7, 84. Height of 9, 1/3 of 9 is 3. 3/84 is 240, 252. Yep, 252 miles cubed. Cha-ching. So that one's fast. Now, doing surface area for this one, this one's going to be rough because I see I have to find the area of the bottom. You know, that's a piece of cake. That's 84. We've already done that. But now I have two skinny triangles over here on the ends. You know, this is what I'm calling the skinny triangle. And then over here is the other skinny triangle. And then we got two fat triangles, big boned triangles. So you got this dude in the front, and then this blue one, his matching partner in the back. All right. So, and the problem is, I got no heights for either of those suckers. I got no slant heights. So we got to grind a little bit. So I'm going to do that Pythagorean trick again. So let's go for the skinny slant height. If I want this skinny slant height right here, I'm going to make myself a little right triangle. I have a side of 9. Since this side was 12, I know that's a 6, and I should be able to use Pythagorean theorem to get that. I'm going to not bore you with that in the video, but I ended up getting somewhere in the neighborhood of 10.8 when I did that Pythagorean theorem move. So I should be able to knock out the skinny triangles. I have two triangles, which are 1/2 base times heights. And then I'm going to come back and I'm going to get the blue triangle. So I come over here, I need a slant height, and then doop, make my little right triangle coming the other way. And since this is 7, this little piece is 3.5. This is still 9. And when I Pythagorean theorem that dude out, I got about 9.7. And so I'm going to have two more triangles at 1/2 base, which is 12. It's kind of sloppy, but I'm running out of real estate here. So now I have rectangle, two triangles, two fat triangles. I slap all that stuff together. You know, this was 75.6. I think this was 116.4 for a grand total 276 square miles. That's a big old triangle. All right, that's the toughest one. A double Pythagorean theorem problem. It's no joke. All right, I think now we're into the word problems. This shouldn't be too bad. A dunk tank is in the shape of a rectangular prism with a square base. So guess what? I better draw it. So dunk tank, square base, copy, paste, choom, 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 choom. There's my dunk tank, 4x4 it says. We're talking feet. I fill it with water to a height of 5 feet. I don't know why my water's red, but my box was blue, so I couldn't make my water any other color. So this is the water, you know, in this area. And it says calculate the volume of the dunk tank. So it's just a box. So the volume is, and maybe it was all the way up to 5. I don't know. But length times width times height, that's the only number I have. So that comes out to be 80 feet cubed. So 80 milk crates, roughly, could be stacked in there. Find out how many gallons of water are needed to fill the tank. Round to the nearest gallon. Now here's a nice little conversion, except for 1 cubic foot. 1 cubic foot. So 1 milk crate holds 7.48 milk jugs. 7.48 gallons of water in 1 cubic foot. Well, we have 80 cubic feet. All right. So we have 80 cubic feet, and every cubic foot weighs or has a volume of 7.48 gallons. So when I crank those two numbers out and I multiply, check my sheet here, it looks like you're going to have 598.4 gallons, which I guess it says round to the nearest gallon. So 598, that's a lot of water in that tank. Now, if we want to take it to the next level, I know that roughly a gallon of water is somewhere in the neighborhood of 8 pounds. So if I times that by 8 lbs, 8 pounds, 600 times 8, holy smokes, you're talking somewhere 4,800 pounds of water. You know, over 2 tons of water in that dunk tank. You know, that's why I've read or seen people online that have built hot tubs on a deck that's not supported very well, and they start filling up. You know, my hot tub holds 500 gallons. You start filling up 500 gallons of water and get 4,000 pounds on there. Sometimes it brings decks down if they're not built to support that. So just a little something, something. Be careful. Moving it on down. How many cylinders below would it take to fill the cube? So fill would be volume. So this is a cube. So it's really 3 by 3 by 3. So this dude has a volume of 27 cubic feet. 3 times 3 times 3. This shape over here is in inches. So I'm going to have to do a conversion here in a minute. But let's get this volume. This volume is base area times height. So pi 3 squared times 8, 9 times 8, that's 72 pi, which is somewhere around 226.2 cubic inches. Now here's my dilemma. You know, this is cubic feet, this is cubic inches, which is much smaller. So I have to find out a conversion there. I got to kind of figure this thing out. 2 different ways you could do it. You could change this into a cubic foot if you wanted to. You could also change this into inches. You know, I think a lot of kids might find it easier to change this one into inches. So 3 feet is really 36 inches if you multiply by 12. So if you want to, think about this box as 36 inches by 36 inches, 36 inches. That's a crap ton of inches. You know, 36 to the third, that's 46,656 cubic inches. Divided by, this little can here only has 226.2 in it. So there's going to be a whole bunch of those. And you start pouring them in and you divide it out. It ended up being somewhere around 206 cylinders. So 206 little, you know, that might be like the size of a paint can right there to fill up, you know, a cubic, 1 yard basically is what this is, because 3 feet is a yard. So, you know, you could call that 1 cubic yard 27 cubic feet or 46,656 cubic inches. Whew, it's a lot. All right, now we got the big dog. This is the last problem. It's pretty tough. Volume isn't too bad. Surface area is going to be a beast. So we'll do volume first, and then I'll erase it, and I'll come back and do surface area. So volume of this box. I'm going to ignore that little nub on the top there, and I'm just going to pretend, you know, we just have a box. So I'm going to ignore that little thing on the top, and my box is 18.8 by 12, length, width, height. So the volume of the big box is 18.8, 12 for a grand total of 1728. And then I'm going to add on this little red box up here, that dude, which he is 6 by, I got to look down here to get the width, it's 8 by a height of 3. So 6, 8, 3, and that comes out to be 144. That's a 3. And for a grand total of 1872 cubic centimeters. So volume's not too bad if I poured water in that thing or whatever. And volume's really important in science if you want to find the density. You know, different elements and different materials have different densities, and you can find the weight of it. If you know the volume and you know the density, you know, there's a DMV formula you can figure that out with. All right, surface area. This is nasty. So bear with me. There's a lot of pieces here, a lot of surfaces. So, man, where the heck do I begin? Let's go the easy ones first. The easy ones first are the bottom. So that's 18 times 8. This side over here, so that's 12 times 8. Then he's got a matching partner over here on the other side. I'm just going to times that by 2 instead of doing another 12 times 8. So I have 2 of those 12 times 8s. So I got the front and the right and the left taken care of. Or no, the bottom, the right, and the left taken care of. Now I got to kind of try to knock out, and I'm just going to do it like this. There's lots of ways to do it. I'm just going to find the area of this front face, and I'm going to match it to the back. I'm not going to worry about this little piece right here right now. So that is 18 by 12 tall, and I have it in the front and the back. So I'm going to do an 18 times a 12, and again I have 2 of those for the front and the back. Then I got to add to that this little doggone piece right here to finish the front, which is 6 by 3. But then there's one more on the back side back here that's also 6 by 3. So I'm going to have 2 6 by 3s. It's getting to be a lot of crap here. Now, so what do we have left? We've got the whole front taken care of, the whole back taken care of, the right, the left, the bottom. What we need now is the top. So the top, there's a lot of little pieces here, and I'll try to color code them. You have this little face right over here that I'm gonna have to do a little bit of math. If the whole bottom's 18 and this middle portion's 6, you know that's leaving a 6 and a 6 on both sides. And again, we know that it's going 8 back. All of these pieces go 8 back. So I have a 6 by 8. So I have a 48 in this piece, which means I have a 48 in that piece. So man, I got 2 48s. And then I can't forget about this little sliver going up. And then over here, I got one going up that we can't really see. It's hidden back there. And that joker is 8 deep by 3. So I got a couple 24s. Good Lord. Who picked this problem? And then on the top, I haven't done this dude yet. Last but not least, that guy who is 6 by 8, which is another 48. Man, that's a lot to punch in your calculator. Whew, I think when I did all that stuff, and if you look on the solutions, it kind of might lay it out a little bit better about who goes where. But I had a grand total of 996 centimeters squared. You know, so if you go check out Schoology and you go to this page, I think it comes up right here to the solutions, and you go all the way down to the bottom. I think that kind of gives you a little bit better idea maybe of what pieces end up going where. So I can see like this was 48, this was 24, 48, another 24. I kind of labeled all the pieces maybe a little bit better. But all right, well, good luck. Hopefully it gets you ready for the test tomorrow. See you.